All right, let's get started. Hello, everyone. I just want to thank everybody for participating in our Allplan webinar, Design and Detailing for Precast Buried Structures. Allplan AEC is one of our new packages this year. My name is Donnie Henry. I'm our Business Development Manager for our precast industry, specifically our buried structures. So any questions or concerns after this or going forward, I will leave my contact information at the end. Feel free to reach out to me. I am joined by Frank Holtz. He's our technical consultant manager. He will be demoing a culvert, a vault, and a catch basin, and showing off Allplan AEC. So Allplan AEC 2022 stands for the Integrated Working Method of Architects, Engineers, and Contractors on a single platform from the initial design to successful implementation on the construction site. So if you're not familiar with Allplan, Allplan is one of the few softwares where you can work in 2D and 3D. So you can still do your drawings in 2D, and Allplan will automatically produce a 3D model on the same interface for you. So work in 2D, 3D seamlessly, efficiently, quickly, and accurately. Automation will reduce errors and check time, reduce the time it takes to create production drawings while still creating high quality and reliable construction drawings. So key components in the webinar today, there's 2D templates, 3D templates, there's Smart and Python parts, and automation is going to be key to the whole webinar. So automated reinforcement, automated quantities, and plan creation. So again, trying to make it easier for all precasters, more efficient, accurate, and much quicker, hence the automation. So you'll learn, the key objectives you'll learn today is automatically generating 3D model structures, generating reinforcement, generating accurate fabrication drawings, and automatic calculations of quantities, weights, volumes, and center of gravity. With that being said, I'm going to pass it over to Frank to start the demo. Any questions you guys have, save for the end. We have a chat box here. We'll answer as many as possible at the end. But with that, I'm going to pass it over to Frank. And again, there you go.
Thank you, Donnie, for that introduction. Today we're going to be looking at some precast buried structures. First, we're going to be looking at a double run box culvert. And we're going to first start with some generic automation techniques and then move into some specific automation techniques for our box culverts. And then we'll look at some of those for our catch basins, our vaults as well, including our new functionality, the automated piece ticketing. So without further ado, we're going to roll right into our box culvert here. I'm going to go to a blank project. All that's in here right now is a underlay. So this is a 2D PDF that I've brought in. Allplan can take in and put out all kinds of different files, AutoCAD, MicroStation, any 2D, 3D data that you want to get into or out of Allplan. You can easily do that here. I'm going to first begin by placing a profile, a culvert profile, down in my plan view. So I just want to place this right at the corner of my box culvert. And now I'm going to open up a couple other views here. I have my central perspective, an elevation view. These are all related back to the main 3D model. And they're all live views into that 3D model. First tool I'm going to use is my extrude tool. So I launched that with a keyboard shortcut that are fully customizable. Now I select the object that I want to extrude into space. And notice as I move my mouse, it's actually showing me a preview of that extrusion. If I want to, I can snap down directly to a point in my reference view, or I can actually type in a specific length. So here I'm actually going to do a 100-foot length culvert run. And so now we can see that full barrel in our perspective and in our plan. At this point, I'm just going to hide the underlay. I don't really want it. We're going to just be working directly on the culvert itself. The next tool I'm going to use, I'm going to access that by right-clicking on the object. Any object that you click in Allplan is going to give you the tool specific to that object, so it makes it really easy to find what's available to you. That first tool I'm going to use on it is my slice tool. This one simply lets me select a couple of points, and then it will cut it in plan for me. I can cut this in any view or section that I want to. Right now I'm just cutting off the ends for a skewed end culvert. So nice easy plan cut there. Once I'm done with that, I'll go ahead and delete those. Now I have my skewed culvert run. I'm ready to cut this into individual pieces of precast. So I'm going to go back to my library. I'm going to pull out another section here. This is a 2D cross section of a shiplap joint. And we can see that it's already set to be placed right within the center of my wall. I just got to come here to the end, and then I can do a delta X offset, say 15 feet, to give me a 15-foot edge here. And we'll notice that this already has the joint built right into it. And what I want to do is actually use this cut to cut all 4 walls of my culvert at once. And so what I'm going to use next is a extrude tool, which takes a profile and a path. First, I'll create a simple rectangular path for this profile to follow. Now I'll use the extrude tool, select my profile, select my path here in 3D, and we can see that it creates a nice cut section for us. Now I actually have this saved in my library already as a slicing section. I could have used that, but I just want to show how easy it is to make some of these things on the fly. Now using my regular CAD routines, I'm just going to copy this, say 15 pieces, and let's do it for 5 foot on center. So now we can see we've added all of those. It looks like we have one too many, so I'm going to go ahead and just hit my delete key. And finally, I want to make these 2 skewed end culverts the same mark number, the same exact shape, so I'm going to mirror my cutting objects here. So I'll just activate that tool, click the line I want to mirror across, and now I have the same skewed ends on both ends of my culvert. Now I'll actually perform the cut by using subtract and remove. So I'll select my main objects, I'll select my cutter objects, I'm going to ask it to resolve it into individual 3D precast elements here. Once I've done that, you notice that I mouse over it, it's actually highlighting, showing that each of these individual segments are true precast element segments. They have all the joint information that you need in here, and everything's ready to go at those individual segments. Now we may want to add head walls to the skewed ends. We may want to add different openings and whatnot. So we can go down and knife and fork these if we want before we make a copy of it, but I'll just go ahead and make a simple copy right now like we did before. So just track it down at 45. Obviously we'd snap to a specific location, but here I'm just placing it over a little bit to show that we now have our double run box culvert. Now at this point, we can get quite a bit of information out of here. The first thing I'm going to do is actually just assign these a quick name, call them culvert, and then we'll be able to get a schedule out of here. So I'll say this is my culvert, and I'm going to run a schedule. And here I have a simple one I created, just names, weights, and volumes. You can see that we have 26 of the regular pieces, 4 of our end pieces, and then those 2 pieces that we have over here. Now I can actually go ahead and start marking these, assigning these. This is one of our generic techniques. I'm going to show you a more automated technique which actually identify the identical pieces for us. But for now we're just doing this in a manual sense with some of the out-of-the-box tools, the basic tools of Allplan. So I'll call this section A. And as soon as I do that, you can see it's updated in here, so it looks like we got the right 4 associated. Now I'll select all I believe what are my B sections, and I'll show you how we can verify that in a second. So I'll call this section B. And then finally my section C here. Now if we look, we can see it's reordered it, alphabetized it. We can organize this any kind of way we want, filter out stuff real easy. And if we make a change to this culvert, let's say this whole thing gets a couple of feet longer, and we decide we want to actually have these 2 pieces get longer for some reason, we can see now that we have these 2 section Bs that are of a different volume and a different weight, and so it's indicating that to us, so we can easily come in here and call these maybe section D or something else if we needed to. All right. So now that we have our main model, we're going to go ahead and look at a single segment of culvert. So I'm going to take one of these interior segments here first. I'm going to flip over to a different drawing file, which is like a layer in AutoCAD, but it actually has a separate file on disk, which makes it real easy to discretize all this data, have a lot of people working on it at once, or maybe one person does the main model, other people go in and do the details. Lets a lot of people work on it all at once, or if you have a really big model and a slow computer, you're able to just open a portion of it at the time. Alright, so now that I have my culvert here off in space, I'm going to cut some sections and some views of it. So the first one I'm going to do is a side view, and basically I just choose the direction that I want to view from. I can set all kinds of options about visible, hidden edges, finishing, clipping paths. We can actually assign material properties to this, so when it gets cut, it will actually put a pattern or a fill or a hatching in there to indicate what the material is. So first I'll set down my side view there, or my section view. Now I'll do a side view. Finally a plan view, and I'm going to rotate this by 90 degrees. And so this is kind of already the workflow that you're doing today, right? You're creating a bunch of 2D sections, placing them down in a model space or a paper space. Oops, looks like I placed an extra one there. But at this point, if we were doing this in 2D, we've already caught up to ourselves. After making the 3D model and all the other 3D work we've done, it's generated these 2D objects. They're all live linked back to the model. You'll see that as I make changes to them, it's automatically going to be updated in real time for us. So now that I've created some sections, I'm going to go ahead and use my reinforcement tools. The first one is an area reinforcement. This is great for walls, slabs, anywhere you're doing a big mat of reinforcement. You want to kind of lay those bars out, like I said, in a transverse mat. So I've entered a 2-inch cover, so now it's showing us the edges and where the cover is going to go to. This is meant for single slabs, single walls. We have a double wall, double slab structure here, so we can actually define the layer position to make sure that it's the right spot. It gives us a nice little yellow preview indicating that. Now we need to enter the member thickness. You can see it's getting the full width. I just want to do this one wall here, and so I want to either type in 8 inches, or I can click 2 points on my screen after clicking the input, and it's actually going to read that data right from the model. So that's one great thing about Allplan, is you're not having to re-enter this data over and over. You're able to just go and pull that data from the model. Once I hit OK here, it's going to give us a preview of these bars. I can put them in any direction that I want. I'm going to put these vertical, so I'll just click on a vertical line here. Next, I'm going to want to add some hooks to the end. So I'm going to go ahead and do a simple hook and just choose the size that I want to place a hook on. Enter my spacing, my bar diameter. It's going to calculate my rebar area, square inches per foot. I can get one from the other. There's all kinds of options in here we won't get into. A lot of options in a lot of our reinforcement tools. We can handle benching if we have a skewed structure and we don't want to have too many marks. We can also, if it's a very large mat, we can cut, splice, stagger these things. We can choose how we want to do same or different marks. And once I hit OK, it's actually going to take it from our preview and place it here in 3D for us. Let me change the scale. Now I can place down my dimension. Notice that as soon as I create the bar, it's automatically going to ask me if I want to dimension it. And in Allplan, that's as simple as choosing, checkboxing the information that you want to see. These bars are really intelligent. They know that they're bars. They know everything about being a piece of rebar. And so they're easily able to get that information and put it into labels, dimensions, and schedules, as we see later. All right, so now I want to match this reinforcement with a horizontal bit of reinforcement. So all I got to do really is hit OK twice. If it's the same size spacing, it will place that there for us and then ask us if we want to put a dimension, of course. We don't always have to put bars down fresh using our bar tools. Of course, we can use our regular CAD routines. So here I'll use a simple mirror and copy, and then just mirror across the midspan of my structure. The next bar shape tool we're going to use is the bar shape tool. This is really great. It does a lot of different shapes for you out of the box. Expand and adapt to the edges, so automatically find rectangular sections for placing stirrups, straight bars, open stirrups, L-shaped bars, corbels, hooks, loops, spacers. You can even draw a line 2D or 3D and then convert that into a bar if you'd like. The first of these tools I'm going to use is our freeform. This is great. It lets you draw really any shape. You just kind of draw along the extents of the concrete. And so you can see it's holding that 2-inch cover that I've specified, and now I'm able to just select the edges of my concrete and draw the bar to wherever I want. If I go too far, I can always undo, of course. So I'm going to take it back just to put a simple straight bar here up the top. And if I want to add a hook or anything else, it's as simple as checking a box. It's going to automatically calculate the bending pin factor, the hook length according to ACI, CRSI. You can also override that on the fly here. So if I want a 4-foot hook or something, or a different bending pin factor, I can do that. If you have a company standard that a number 14 in 4 KSI concrete always gets a number 4 hook, you can set that as the default so you don't have to type that and override that every time. Alright, so with the bar shape tool, once I shape it, it's going to ask me if I want to label it. It's simple as placing a label down like we did with the dimension. After I label it, it's going to ask me to place it. The automatic placement works really good for our simple rectangular structures. If we have something more complex though, all we need to do is choose a start point and an end point, and it'll place those bars along that placing line for us. Again, we can enter number of pieces, the spacing, calculate one from the other. We can do covers at the end, take-ups at the end, all kinds of things you need to do to place this placement of bars here. And then, of course, after I place it, it's going to ask me if I dimension it, if I want to dimension it, and then automatically bring that tool right back up so I can start the whole process over again. Just like I did before, I'm going to go ahead and copy it, but I'm even going to copy it with the label. And when I copy the bar and the label together, it remains associated. So if I end up changing this bar down here, it will actually update that label there accordingly. And these can be separate marks, same mark. It's real easy to separate them out. That's what the colors actually indicate, are the mark numbers. You can mark that color by mark number. You can do it by diameter, reinforcing grade, anything that helps you visualize the situation. Now that I have some bars down, I'm going to go ahead and create one of our many schedules that we have out of the box. These are actually completely customizable, so anything you want these to look like, it's really simple. It's actually part of the implementation process. We help you with it. You send us over your PDF with your schedule. We take out the column header, that first line, put in a series of placeholders, and now it's going to fill out this data for you. So you can see it's getting the mark, the pieces, the size. We can even do the bending shapes with the ABC dimensions. These are really important for rebar detailers, but in the precast world, a lot of our customers now are starting to use bar bending machines, automated bar bending machines. We communicate directly to those. We also support exports to ASA and Sule, so if you're running multiple precast plants, producing everything at one plant and then shipping it around your local area, those bars, we can help you with we export it to ASA or Sule. They'll help you with the management, the tagging, tracking the shipping, and the installation and all that as well. So very powerful data-centric stuff here. And like I said, it's completely customizable to what you guys want that to look like. Now, if I didn't notice at this point that there's collisions here, I can run my collision check tool. So I'll do that now, and I'm just going to check all my bars against bars. But this tool has many uses, not just bar against bar. We can also check precast against precast, make sure we have fit up in the field. Here we can see that the bars, it puts nice big red boxes around it, indicate that we have a problem. Once I hit escape, it asks me if I want to save it. So if I was the checker and I found this problem, I can save it for the drafter to update. Or if I just want to deal with it myself, it's pretty simple. You just come up here, you hit M for move, and then you're just going to move your bars down. And I got the first top half. I got to select them together, but it's easy to do both at the same time. So now we have this perfect lap splice here that we wanted, and all that collision's out of the way. Alright, so the next thing we're going to do is add an opening to our culvert here, just an opening on the side. We could have done this at the main model, or we're doing it here. It can be done at any point, right? This could actually been a previously done project, and now I come into it because it's substantially similar to the one I'm working on today, with the exception of this opening, or maybe it's a taller culvert section or something. And so we'll just go ahead and make some of these changes here on the fly. Alright, so first thing I did was cut the opening. We can see that the bars and the reinforcement, we can control those separately. So if we do need to keep this opening reinforced for shipping, we can do that. Usually we don't have to have the horizontal bars, so go ahead and get rid of those first. So I come back to my geometry dialog box. I'm going to say I want to enter an opening, and then I'm going to use my area detection tool. This is great for all kinds of shapes of openings. You simply just select in that area, it finds that opening. Let me just make sure we're on different marks here, so it gives us different mark numbers. And we can see that new colors indicating new marks. I'll go ahead and do the same thing for the vertical bars here. Oops. And again, just make sure these are placed on different marks. Once I've done that, we can see again more colors. If we go back to our schedule, we'll see that's updating in real time. It's identifying all those separate marks for us, changing the bar shapes, everything else, getting all that dimensions in real time. All your weights, volumes, all that stuff is updated immediately. Now let's say we want to make another change. We just want to make this culvert, say, a couple of feet taller perhaps. I just stretch that down, stretch downwards. And we'll notice that not only is it making these bars longer vertically, but it's also increasing the quantity of the bars horizontally. And we saw that not only did it update our schedule and the bars, but it's also updating all the other views and sections as well. So as I undo, redo here, we can see that effect being made. All right. One last thing we're going to do is add some lifters to this. So I can go here to my modeling tab. Any generic 3D object, we're able to get the center of gravity on that real easily. Just basically click the object and it's going to place in 3D a crosshair for us to use. And now I can place my lifters around there one by one if I want. We also have some tools that help you place lifters, 4 lifters in a section around the CG of something. So I'm going to come here, snap to my top, so we can see that it's stuck to my top surface. Now I just choose that center of gravity, and I'm able to control the offset of these things together, so it makes it real easy to keep them equidistant from that COG while avoiding conflicts with the reinforcement. If we do have conflicts, we can always find those with the collision check. No problem at all. And we can see our lifters in the place where we want them. All right, so all of this was done with what sometimes is called manual techniques or generic automation. Now we're going to look at some specific automation, 2 culverts. So I'm just going to kind of blank everything out here. And in our library, we're going to go to some of our default Python parts, or apps as we call them, for our buried structures. A lot of different classes. We'll be looking at a couple other ones here today. First, we're going to start with our culvert. So it's as simple as launching it from the library, placing it down in space, entering some parameters. So we have our clear span, clear height, segment length. Do we want a bell, a spigot? If so, what are the joint parameters? Reinforcement as well. We can do it as mesh. We can create a cast in place zone. We select our bar configuration. All the common ones are in here. And then it's just a matter of filling out our size spacing pairs that we got from the engineering program or from our engineer. Once we've done that, we can see that it's creating all these bars for us exactly where we want them. Let me go ahead and make the concrete invisible real quick. So now we can see all that hard work that we did getting it in manually. The automation does it all for us. It's going to, cut and splice these things perfectly. It's going to have the right amount of overlap where we want it right in time for us. All right. So now I'll go over to my layout editor. This is like our paper space in AutoCAD. It's where we bring all of our stuff from the model space into here, place down a series of viewports. It's exactly like you expect. This is a 40-year-old CAD platform. It's older than AutoCAD. So all that 2D behavior that you expect, all those 2D tools you expect, they're absolutely in here as well. So you can see it's just a matter of placing down the viewports that I've previously created and discretized. And finally our schedule here. And so you can see that just like in AutoCAD, it's just our 2D renderings put on our paper space here. Our title block, these are actually automated, so they're pulling information not only from the model but from the project. We also have layout attributes as well, who checked it, who drew it. You check 30 drawings that day, you can press one button, put your name on all of them. It also is good for plotting and publishing. I can say I want to see all the things that have been drawn but not checked. Or maybe if I'm releasing, I want to see all the things that have been checked but not released so that I can print exactly the stuff I need to. All right, and just to show a little bit of that basic CAD functionality, I'll just draw a circle here to make a nice detail. So it's really easy to come in here and crop things with any kind of shape that you want. Place down text, of course. All the multi-line text, everything else that you need is in here. Oops. Opening detail. And place a leader if I'd like. So all that 2D behavior that you come to expect is in there. Getting a lot of that stuff pre-created, all the line work, all the reinforcement schedules, all that stuff now is completely automated, and then it's up to you to kind of craft this 2D space, get the aesthetics, the information density, the white space, all that stuff dialed into the way that your engineer or your client wants it. All right, so now that we've looked at a culvert, we're going to go ahead and look at a catch basin and some volts. So the first thing I'm going to do is look at a series of volts that we've created for some customers just to show off the functionality of it. So let me go over to a different drawing file. And so here we can see just a few different volts, like I said, showing off some of the different tools or functionality inside of this app or Python part. So we can see that it's going to automatically hold back our bars around openings. It's going to create supplemental replacement steel. Replacement steel, every time you cut a bar, you need to replace it on the sides. If I double click on any objects, you can see that they're parametric. They stay parametric, kind of like our culvert. You enter a series of parameters. Here we have the height split. So I want an 8-foot riser, an 8-foot base. We have our inner dimensions, slab thicknesses. We can choose to, cut the top slab off or make it, a clamshell device if we want to. We can do a drop key. As you can see, we have ledges that come off the side. We can do any kind of joints and define the parameters of those. We can do baffles. We have multiple holes, round and rectangular. They can be combined up to create unique shapes. Notice that we're placing lifters, pull steels, terminators, boots at openings. With regard to the reinforcement properties, a lot of options here. Reinforcement, rebar, mesh. As I mentioned, we can do replacement, supplemental steel, set all the covers individually. Control our slab reinforcement, top and bottom slab separately. Additionally, we can do top mat, bottom mat reinforcement in each of those slabs. Walls as well. We can do a single layer of reinforcement, centered or not, multiple layers or a double layer of reinforcement, an interior and exterior layer of reinforcement. Controlling the risers and the base separately, of course, we need to do that. We have a lot of cover options. And we started with just a few, but over the years, our customers have requested more and more. And we listen and respond to you guys, and we've added those. So now there's a lot of covers in there for all the kind of different directions that you need. So like I said, just showing off a few of the different volts that I've been privy to from our customers over the years. They're all different shapes and sizes. They incorporate different fixtures, as we call them, these kind of inserts, whether they're lifting inserts or terminators or boots, what have you. So any kind of shape you can really imagine. You can model it, reinforce it in Allplan, and with our basic shapes, you can model and reinforce it almost instantly after you enter the parameters. All right, so now I'm going to go back to my blank drawing here, and I'm going to use a fresh app, a fresh Python part from our library. It's going to be that volt one, and we're going to go ahead and make a catch basin with that. So I'll just double click my object here. I'm going to go ahead and load a favorite. Favorites are really powerful. It lets us, load all of these parameters in, so we don't have to retype them every time we have a new project. We'll see later how we actually have already seen how we can reuse work from previous projects. But it's nice, to have all this stuff pre-entered for you. A lot of rules, covers, spacings, these kinds of things can be stored in here and saved for later. All right, so real quickly, I've just created that catch basin. We can imagine how to create this ourselves by hand, but we just use the Python part tool to generate that reinforcement, the lifters, and the basic shape for us. And now we're going to add some additional things to it, things that could be added through the app, or we're going to do it in this case manually, just so I can work back and forth with that. All right, so first thing I'm going to do is place down a grate. So I'll go to my fixture catalog. I have hatches. I'm going to do a regular frame grate. Just like I did before, I'm going to snap it to the top, and now I'm going to use my midpoint tool. And we can see that it's placed my grate at the top. At this point, I'm ready to convert it into a precast element. What that really means, I'm just applying some properties to it. So I'm saying that this is a volt. It's using a certain type of concrete. I'm going to apply some attributes. So I'm going to say the top of this guy is 78 feet in the air. I could lay these things out in a true 3D sense in the project if I wanted to, and have it actually read that top elevation of my catch basin here. But a lot of times you're getting a handwritten list of these things. You're not even knowing where they are in the project. So we can just make it easier here, enter that top value that the contractor has given us, and assign that as attribute data. Now I'm going to associate my reinforcement and my inserts with my precast element here. So now when you see that I selected, it's all associated. Anything else that I place now that's created as a precast element will automatically associate if it's touching the concrete. And with a precast element, we can use our automated element plan tool. This is new to 2023. It was always in a different version of the program called Plan Bar, but now we're opening it up to all of our customers. For additional fee, of course, this is our AEC suite, and what you get access to is this precast element tools, and more importantly, this element plan, which is going to automatically generate an element plan or a shop ticket for us. So I select first the scale. I can choose one of many different layout templates, and it will go and cut those sections automatically, create those labels automatically, pull all that attribute data, create the schedules, place those down for us. And so we can see here, it's done quite a bit of stuff for us. Like I said, it's created an isometric view, it's dimensioned, it's labeled, even the sectioning, A, B, C, D, it finds exactly where these things are cut inside of the model and places a clipping line there. It's going to label them. If I change one from D to E, it will automatically update that as well. And let's see how these templates are created. So if I click over here, I can quickly edit the template. I'm just going to zoom out maybe over here. Oops. There we go. Just put these side by side so we can see what's involved in creating these templates. This, again, is something that we do for you right out of the box during training implementation. We have some templates available to customers. We're developing them all the time. We're modifying them all the time. We teach you how to do that as well. But you can see it's pretty straightforward. I select if I want to place, I have a legend over here, a schedule. I have my title block down here. I have some views and sections. It's pretty easy to create. You choose the direction you want to view, choose a rotation. You can say the start and stop, as a percentage of the element itself. As I mentioned, you can turn on clipping paths. You can turn all kinds of labels on, dimensions, dimension lines. Do you want to see the overall geometry, the fixtures, the reinforcement? How should these things be labeled? You set this up, you save it as a template. This one section can be saved as a template. You copy it around to all the other element plan templates that you have. And in my mind, this is getting as close as I've seen yet to what I consider to be the holy grail for precast and simple classes of structures, where the modeling, the reinforcement, it's all done in a very automated sense specific to the structure because, they're so simple and rectangular, we're able to do some of these things a little more easily. And we've expanded to larger structures as well. This was originally developed for walls and slabs, and now we're taking it to precast buried structures. And we can see how well it does with the vault. It does really well on culverts and other ones as well. All right, so let's add a little bit more detail to this guy. So the next thing I'm going to do, and actually I'm going to have both my drawing and my model open up side by side here. And from my fixture catalog, I'm going to bring in some blockouts. So here I have a 6-inch diameter pipe with an 8-inch diameter void. And I'm just going to place this right here on my first face, which would be section CC. And I'll just do it up right at the bottom of the culvert. So this will be our drain out. So I'll do 4 inches up. And you can see as soon as I place that, the drawings are automatically updating over here. So not only has it labeled it, it's dimensioned it, it's indicating the invert location. This is actually coming from this top 78 that we've placed, so it knows the distance between the top and the invert here, and it's going to automatically calculate that. You can see it's doing an absolute dimension. We can do relative, absolute, whatever makes sense for what you're working on. I'll go ahead and place just one more here. Show you how easy it is to first rotate it into position, and now I'm going to do this 1 foot up. And so now we've placed that. We can see the inverts. We got 74 and a half, 75, 1/7, so 2 inches here. And remember, it's coming off of that 78. So if the top of this one changes, or perhaps I just make a copy for the next one in our project, and I want to change it to right down the street, it's maybe say 80 foot up. So I go back to my precast element. I'm going to edit my attribute data. So here's that 78. Notice that it's 74.5, 78. As soon as it changes to say 80, it's going to immediately update everywhere. So here we can set that's 2 inches taller now, that's 2 inches taller now. So any place we're making all of this change, this attribute, this intelligence modifications, it's actually going to update automatically in real time. If I move this perhaps, let's say I move it up 5 inches or so, we're going to see that it's going to automatically update any dimension, any label that was placed into it. They're all immediately reflecting what's happening inside of the model. All right. And with that, completes our demonstration portion of the webinar today. I hope you got a good sense of what it is to model, reinforce, create drawings inside of Allplan, both in our generic automation routines and our fully automated specific routines. And with that, I'm going to pass it over to Donnie to wrap up, and we'll go ahead and do a Q&A at the end. Thank you.
Thanks, Frank. That was great. Lots of good information there. Again, if you want to see more or want a personal demo, let us know. We can actually provide that. But now we'll open it up for any questions. Simply use the chat box down there to your right and ask any questions, and we'll get to as many as we can. Thanks, guys.
Okay, so who can I contact for the demo? You can contact us, 484-354-3604. That's my direct line. Our email, my email is dhenry@allplan.com. This webinar is something is there a version of the recorded webinar? There is on allplan.com. If you go to learning, all our recorded webinars are there. Can you own the software or run it? You can do both. You can buy it outright. We do have a 1-year and a 3-year subscription. I can give you guys more detail on that. The second one, okay, here we go. Does it work well with large projects with many marks? Frank, can you go ahead and answer that one?
Yeah, absolutely. We work with large teams, large projects. It's real easy to split up all the data and turn it into lots of individual files and let them just act like layers as they would in AutoCAD. So big projects, big teams, not a problem for Allplan, and uses very uses our resources very efficiently. And so even if you do have to open up the whole project at once, you'll find it much faster than other softwares as well.
Great. And another one here, system requirements for Allplan. I know you need Windows 10. Can you elaborate a little more on that, Frank?
Yep. So Windows 10 is now required for, I think, the 2022 version and onward. You don't have to upgrade to Windows 11 just yet, but they are very light in requirements, less than AutoCAD. Actually, the newer versions of AutoCAD are as hefty as the current versions of Allplan. So if you can run that, you can definitely run Allplan. We also have on our website a system requirements list, as well as a test my machine. So you can press a button, it'll run a bunch of tests and make sure you have adequate hardware.
Great. And the last one here, do you guys have classes? Frank, we don't necessarily have classes, do we?
We do. I mean, we have when people first start in the program, they have access to our learning management system. So they go through, they watch those. We have weekly help sessions as people are getting into it. For our existing customers, we can do follow-up sessions. Usually those are just included in your maintenance, especially if there are things about new features, or you have some of the basic questions that everybody has using some of the more advanced features in there. If you want to have new people come on and they want the training from the start, we usually provide, extended access to the learning management system. The help sessions, then if we're getting really intense and we're taking people from 0 to hero, then there might be additional costs, but usually just to learn things, learn from us. You just want to set up a call, you want to find out about some advanced features, or we get from a lot of people where they have a specific structure that they've never approached before, and they just want to see how the best way, the best workflow, how to tackle that. Our phone's always available. You can always email us. It's probably a little quicker. We have lots of people standing by to get you quick answers for those quick questions. But if it's something more in depth and you'd like some more training, send us an email and we'll be happy to set up. We're just trying to make everybody happy, whether they're a new customer, an existing customer. So just reach out to us directly. If you're an existing customer, if you're a new customer, that's part of the implementation and training that we offer with the package.
And again, my direct number here is 484-354-3604. Our landline here is 610-379-2711. And that looks like it's it for the questions. I want to thank everybody for participating. And again, if you need to see the recorded webinar, it is on our website. And then it's under the learning and then recorded webinars. So with that, thank you guys and enjoy your day.